Okay. Hello, I am back. All right. Hello, I am back. Ready to do lecture one finally. After doing like a couple projects and stuff. Yesterday was a good day. Look, I just forced, even though I wasn't really feeling it, I just forced myself to do just a bit to get that habit of just going into it. Making sure we do it every day. Um, yeah. I haven't had breakfast yet, so we're just gonna watch a part of it, and then I'll have breakfast in the long break. So we're gonna do the week conditionals today. Um, I'm gonna just pull up this thing. We're gonna do conditionals. So this is how I'm just gonna read through this real quick, and then we're gonna watch this lecture, and yeah. So we're gonna start this in a bit. I know or, I know and, elif, and yeah, elif, modular. Okay, so we're up to modular yesterday. Let me just pull up on the other screen my own little thing so we can go through what this means. Oh, if it's divisible by 2, right? Modular is just if you can be divided. 4 divisible by 2 because 3 divided by 2. Yeah, okay. Create our own parity function. Okay, so this just shows if it's divisible. Okay, I understand that. Awesome. Um, code.cs50.i. Yeah, I think generally to become a data analyst, like I have to do projects, I have to create visualizations, I have to answer like tailor whatever problem to the thing. So we're just gonna go and do that slowly once I finish this part of the CS50 course. Um, yeah, so my day is just gonna be like project the first 3 hours of the day, like self-learning because it's best time, and then take a break, do a project on the side, like maybe 1 to 4 p.m. and then job apps at the end of the night or something. And I'll work out in between if I have time. But yeah, I'll probably work out like 12 to 1. That seems like the plan. All right. So parity. You will find it useful to create a function. We can create a function to check whether numbers are adjust your code as follows. I'm gonna write a pseudocode here. Um, Main function to 10 to input x and to see it's have is underscore even. See if um see if it's to see if it's what's on and the is even function. It's sign main to see if it's see if it's odd, even odd, using modulo, and then we return main and a main. Okay, so main function to import. Okay, I'm gonna try to do this without looking, but I'm gonna try. So our main function, so find main. That's the name. We're gonna name function main. X is equal to integer. Input what's X. Space to make nicer. And then because we get a string, so we have to put it in short. Yeah. Oh yeah, we have to use the is even function. So if it is even, is even score even X range else so okay, we're gonna have an is even function. So define is underscore even. Let's say a, just a variable. Let's put a. Equal to 0. We want to return it, so return else false. Well, let me see. Oh no, okay. Line 6 else. Oh, because I didn't put this. What's X? Let's say 5. Oh, fine. Transforms. Let me try again. Oh, awesome. Works. Okay. Now. Because yeah, I think reading the notes before you're doing the lectures is better because because when you're in lectures and stuff, you kind of have like an understanding before you go and do the lectures, because half the time it's going pretty fast and you don't know what's going on. Okay. In the program, there are type of programs that are called Pythonic in nature, as there are ways to program that are sometimes only seen in Python. Consider the following revision to our program. Define main, okay, cool. We have the main function right here, and then we input what's x, and then we have a condition. The function is even. If it fulfills the is even function, print even. If it's else, print odd. Define is even and return true. Oh wow, it's like a sentence. Return true if, and kind of reminds us equal bit, else false. We can further revise our code and make it more and more readable. So x, if it's even under x4, x, print even, else print odd. Define is even, return n, percentage 2 equal 0, main. Notice the program of value is happening within the n percentage 2 as either true or false, or simply return that to the main function. Oh. Okay. Match setting can be used to match a certain value. Certain font. Yeah, so we have all pretty good readability. Alternatively, we can use match to map names to houses. Oh, case. Okay. 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 So it's like elif in a way. Notice the this will match any other. Oh. Okay. The underspace. Okay. A match statement. Okay. Alternatively, we can use match statements to map names to houses. Consider the following code. Name is equal to input. What's your name? Notice the use of underspace. In the last case, this will match with any input, resulting in the same behavior as the else statement. Cool. Match name, case. Oh, we could. It makes it more readable, to be honest. That's pretty clean. Awesome. Okay, we have read our week on 1 conditionals. We're going to go start now. I'll put this at 1 point.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this week we focus on conditionals. Conditionals, or conditional statements, in Python and in other languages, are this ability to ask questions and answer those questions in order to decide, do you want to execute this line of code, or this line of code, or this other line of code instead? They allow you to take the proverbial forks in the road within your own code logically. So how might we go about making some of these decisions? Well, it turns out that Python comes with a lot of built-in syntax. For instance, here are just some of the symbols you can use in Python to ask questions. Admittedly, mathematical questions, but we'll start there, if only to keep the example simple early on. This first symbol, as you might might know from math, represents greater than. The second symbol might not look too familiar because we usually write it all as one thing on a piece of paper. But on a keyboard, if you want to say greater than or equal to, you'd use this symbol instead. This, of course, means less than. This means less than or equal to. And this one's a bit of a curiosity. We've seen in our look at functions and variables how we were able to assign values to variables using a single equal sign. But that equal sign didn't represent equality. It represented assignment from right to left. That's great because it solved that problem, but it kind of left us in a bit of a bind because how do we now compare two things left and right? Well, in Python and in many languages, you actually use two equal signs. So two equal signs represents equality, comparing the thing on the left and the right. One equal sign, as always, represents assignment, copying the thing from the right to the left. Lastly, this last symbol represents not equal to. So the exclamation point or bang followed by an equal sign means not equal to some value next to it. Well, to ask the questions using these symbols or any others, we're going to need another keyword in Python. And that keyword, quite simply, as in English, is if. You can ask questions in Python code along the lines of, if the answer to this question is true, then go ahead and execute this code for me. So let's go ahead and write some of these examples here. I'm going to go over to VS Code, and let's go ahead and create a program first called compare.py, the goal of which is simply to write code that compares values and makes decisions based on those values. Let's go ahead and type code of compare.py in order to create a brand new file called compare in which we'll start to express some of this logic. All right, well, what do we want to compare? Suppose we want to compare, for the sake of discussion, just a couple of integers, but we'd like those integers to come from the user so that we can make decisions based on numbers we don't know the values of in advance. Well, let's go ahead and do this. As we've done in the past, let's declare a variable like x. Let's assign it equal to the return value of the int function and pass to the int function the return value of the input function, asking the user a question like what's x question mark, as we've done in the past. Let's do this one more time with y, asking the user for the value of y, and again, converting that ultimately to an int as well. So at this moment in the story, we have two variables, x and y, each of which has values. And ideally, we should be able to now compare these values. So suppose I want to make a decision based on the values of these variables. I'm going to use the keyword if, and I'm going to use some of those mathematical symbols to actually ask the question itself. So how about this? If x is less than y, then let's go ahead and just print as much out. Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here, x less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression, named after a mathematician named Boole, is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only two possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They are not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good eye here. I don't want to assign y to x if x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run Python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look, perhaps, at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flow chart. It's a diagram of this program's logic, and more technically, it shows the program's control flow. That is the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flow chart, and you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape, and inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2, respectively, for x and y. So, of course, 1 is less than 2. So that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question, and this flowchart captures that as well. The third diamond asks x equals y. Now, that too has a false answer in this case, because 1, of course, does not equal y. And so we again follow the third false branch here. And that leads us, of course, to stop. And stop just indicates that's it for the program. So I think that's correct. And that particular flowchart does happen to represent the actual code that I wrote. So it's correct. It does what it's supposed to do. It answered the question correctly by printing on the screen x less than y. But what is perhaps poorly designed about it? Let's make this first distinction. It's not enough necessarily for the code that you write to be correct and do what you intend. Longer term, especially as our programs get longer and more sophisticated, more complicated, we're going to want them to be well designed too. Thoughts on in what way this program is arguably not well designed, even though it's correct? Let's see here. Khalid, if I'm saying that right, your thoughts?
Too many ifs, I think, is getting repetitive. We can make our code more concise, maybe.
Yeah, it seems a little repetitive. I'm asking if this, if this, if this. And yet logically, I should know the answer to some of those later questions once I figure one out. And in short, if you look at this diagram here, notice that no matter whether I go left or I go right, I'm always asking 3 questions. No matter what, all of those arrows lead to the first, the second, and the third diamond. So I'm asking 3 questions no matter whether any of those answers are true or false. Well, how might I go about improving this? Well, let me propose that we introduce another keyword to our Python vocabulary, namely elif. And this, too, is kind of a succinct one. It's a conjunction of else if in English, which allows us to ask a question that takes into account whether or not a previous question had a true or false answer. Well, what do I mean by that? Well, let me go back to my code here, and let me propose that we now improve upon this here by asking ourselves, ultimately, how can we ask fewer questions? And let me go ahead here and propose that instead of asking if, let's make these conditions potentially mutually exclusive. That is to say, don't keep answering questions once we get back a true answer. So I'm going to change my code up here as follows. Instead of asking if, I'm going to say if x less than y, elif x greater than y, elif x equals y. So I'm going to implicitly, just like in English, take into account that I'm only going to keep asking myself these questions if I haven't yet gotten a true response. Think about the logic here, the English. If x is less than y, on line 4, print out x is less than y. Well, if that's the case, you're done logically. Because if the English is saying if x less than y, else if x greater than y, those are going to be mutually exclusive if the answer to the first question is true. You don't have to keep asking questions to which you already logically know the answer. So let me go ahead now and run this program. And I think the behavior is going to be the same. Python of compare.py, what's x? Let's do 1. What's y? Let's do 2. X is less than y. Now, honestly, I didn't really notice a difference when I ran the program. And honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs. But it's laying the foundation for writing better code longer term. Now, what is the improvement I've just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what, even if I already figured out what I want to print on the screen, this new version of the program that has if, elif might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here. But let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. X less than y. Is 1 less than 2? But notice here, let me zoom out. If 1 is indeed less than 2, we follow this longer arrow down marked true. We print out, quote unquote, x is less than y, but then we immediately follow this next arrow down to the icon that says stop. So that's what's implied by doing if, elif. If we get back a true answer right away to that first if, we're going to print out x is less than y and then stop. We're logically at the end of the program. So this picture is just representing graphically what the code is actually doing. But suppose I typed in something else. Suppose that my code actually ran and I typed in 2 for x and 1 for y. That is to say, the answer to the first question is now false, but the answer to the second question is now true, because of course 2 is greater than 1. Well, let's go back to the diagram, same as before. We start at the very top where it says start. The very first question up here now, x less than y, is an answer of false, because no, 2 is not less than 1. So we follow this arrow to the next question, this diamond. Is x greater than y? Well, yes. 2 is greater than 1. So now we follow this left arrow, which is true. We print out, quote unquote, x is greater than y, and then stop. So what's the improvement? Well, in the first case, we got lucky and we only had to ask one question, and boom, we're done. This time, we had to ask 2 questions, but then boom, we're done. Only if x happens to equal y do we actually find ourselves logically getting all the way down to this final elif in my code. And pictorially, only if x is equal to y do we find ourselves going all the way down to the third diamond, the third question, asking is it equal to y or not. Now, hopefully the answer at that point is not false. We've included a false arrow just so that the program itself is well defined. But logically, we shouldn't actually be getting there anyway, because it's got to be less than or greater than or equal to in this case. Well, let me pause here to see if there's any questions now, either on the code version thereof here or on this diagramming of that very same logic. Questions here on this control flow?
Aren't we supposed to put an else at the end?
Ah, a good question. And yes, so that's going to be my third and final approach. And if you don't mind, let's pivot there right away. Identifying a third keyword that indeed exists in Python that allows us to be even better at expressing this logic, to design this program even better, and that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, L if x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore because logically, if the two conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first two scenarios, logically, it's got to be the case that x must equal y if it wasn't the case that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here. And instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else, just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice
All right. I just did a nasal flush. Felt great, honestly. So, alrighties. All right, let's start.
That it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. Still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked 1 question, or 2, or worst case, 3 whole questions. But we can do better than that. Using else as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows, and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here. And let's propose how we might ask a couple of questions at once this time, perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine is x equal to y or not? Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y, or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we instead want to make sure that it is equal to, we can just use Hope's else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run Python of compare.py. What's x? 1. What's y? 2. OK, x is not equal to y. Let's do it again. But 2 for x, 1 for y. X is not equal to y. And one third time, how about x is 1 and y is 1? X is now equal to y. Now, if we want to compare that visually too, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but it's a pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false. So we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code. And then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I could improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is just equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw on the available list earlier. We can
There's
check
X
not
is
just less
equal
than
to
or greater
Y.
than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's
Yeah,
less
the
than
S-
or if it's greater
the
than? Well, if all you care
exclamation
about
mark.
is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that too, I think, is going to work exactly the same, but the picture now looks a little bit different. Notice that this was our flow chart earlier that represented that same logic, and there's a bit of complexity. You got to go left, you got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler, perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question: is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct. But now the diagram, instead of looking like this, is going to change the not equal to equal equal. And we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly. And one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here. And indeed, it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++, and Java curly braces to connote blocks instead. It relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts. And that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose here that we explore this kind of logic by way of another program altogether in VS Code, whereby I'll go ahead now and create a new program, say, called grade.py. Let's consider exactly what grade a student should get based on their score on an exam or a test or a quiz or some other assignment like that. I'm going to go ahead and run code of grade.py to give myself a new file. And I'm going to go ahead and start by just getting the user's score, again, on some assignment or test or the like. And I'm going to store it in a variable called score equal the return value of the int function, which is going to convert whatever the user's input is when prompted for this score. So again, the user should just oblige by giving me a number like 0 or 1 or 2, or hopefully much higher than that, like 97, 98, 99, 100, assuming the test or assessment is out of 100 percentage points. Now, how can I go about assigning a grade to the student's score? Well, in the US, it's very commonly the case that if you get between a 90 and 100, that's an A. And if it's between an 80 and an 89, it's a B. If it's 70 and 79, it's a C, and so forth, all the way down to F, which should be E, but we'll see that there's a bit of a jump. So how might I express this? Well, I can use conditionals, and I can ask a few questions and then print out the student's grade accordingly. So let me express it like this. If the student's score is greater than or equal to 90, and the student's score is less than or equal to 100, so it's in that range, let's go ahead and print out that their grade shall be an A, because they're in the 90s above grades range. If the score is greater than or equal to 80, and the score is less than or equal to, say, 89. But here I have some options. Logically, I can actually express myself in any number of ways. And maybe just to be a little cleaner, I'm going to say a score is less than 90. So I'm using less than instead of less than or equal to. So I'm making sure that their boundaries between these grades are correct. Then I'm going to go ahead and give the student a B if it's in the 80s. If score is greater than or equal to 70 and the score is less than 80, I'm going to go ahead and give them a C. If the score is greater than or equal to 60 and the score is less than 70, I'm going to go ahead and give them a D. And here's where it's a little anomalous, at least in some schools here. Else, I'm going to go ahead and give them an F. So we're skipping E altogether, and we're going to give an F instead for the grade. So that's the catch-all. And I think logically I've gotten this correct, at least based on where I went to school growing up, such that it's going to give an A or a B or a C or a D. Else, it's going to assume that you got an F. Well, let's try just a few of these here. Let's run Python of grade.py. My score is, let's start strong, 100. All right, I got an A. Didn't do as well the next time. Maybe it's a 95. Still an A. Starting to slip further, so I got an 89 the next time. That's now, say, a B. And let's say I really had a bad week and it's now like a 71. That's now a C. Or I didn't even submit it at all. That's an F altogether. All right, so it seems to work. That's not really an exhaustive test, but at least based on some sampling there, my code seems to work as I expect. But let's see if we can't tighten this up. It's not wrong. It's correct. And indeed, according to my own specifications, I dare say this code is correct. But can we tighten it up? Can we reduce the probability of bugs now or down the line? Can we increase the readability of it? And can we increase the efficiency of it? Can we get the computer to have to answer fewer questions and still get the same result? Well, let's see what we might do. Let me just kind of switch things up, if only to demonstrate that we can use these symbols in different ways. I could say, as I've done, if score is greater than or equal to 90, but I can actually do this. I can flip it around. Instead of saying greater than or equal to, let's say 90 is less than or equal to score. And here, let's say if 80 is less than or equal to score, and here 70 is less than or equal to score, and then lastly 60 is less than or equal to score. So it's the same thing logically. I'm just kind of switching things around, just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can in code in Python do this, which is just a little cleaner, right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. If the score is greater than or equal to 80, the student gets a B. If score is greater than or equal to 70, they get a C. If the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions. But again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditionals, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I had kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if
Oh,
or else?
I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too, to just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark? And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear. A number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Even or odd, let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark? And we've done that before many times. Of whatever the user user inputs after asking them, what's x question mark? And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers, it can divide it exactly by 2. For example, 2, 4, 6, 8, and 10.
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote unquote even and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer. So I'm going to go ahead and print out quote unquote odd instead. And let's go ahead and now run Python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we could do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or .py. And suppose my saying if. Now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python of grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I had kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, I guess, better way to kind of clean up even just this simple statement like we had before, the previous one that you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too, to just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before, this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like 1 divided by 3, 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder of 2. 3 divided by 3 has a remainder of 0, because it divides cleanly. 4 divided by 3 has a remainder of 1, because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that, since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them, what's x question mark? And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear, a number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers, it can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect. And we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that, what is the remainder, we can presumably check, is the remainder 0 or is it 1? Do we have nothing left over, or do we have 1 left
I'm gonna go quick interview pretty soon, so we asked to do a really quick phone interview, so that's gonna be exciting. Yeah.